Now we're going to think about diminishing marginal utility and indifference curves and do some more comparison of points along Keiko's indifference curves and think about that a little more deeply. We started thinking about that at the end of the previous video, but now we want to go a little deeper. Okay, so what we're going to be thinking about here is the idea of the marginal rate of substitution and someone's willingness to pay. So you want to imagine that Keiko has some bundle of x and y, so some amount of living and learning already. Okay, and then we want to think she's going to be offered some exchange. Trade away some of your y, the learning, in order to get some x. Now, obviously that's a little bit strange to think about in terms of living and learning, but you as an individual are making these kinds of trade-offs among different things that you could be choosing at any point in time. So when we think about this and Keiko making this trade, she's thinking about what to do with her time. Okay, so you already know that the marginal rate of substitution tells us the greatest amount of y that she'd be willing to give up to get one more unit of x in such a trade. That's how we defined it earlier. So what this also means, though, is that we think of the marginal rate of substitution as the willingness to pay in y to get more x. So it's how much of the one good you would pay to get an additional unit of x. So imagine here that we could also think of the y good, not as living versus learning, but imagine that y was money and x was some good that you want, say coffee or data or a cookie or anything that you could consider purchasing. Y as money or general purchasing power, we could think about this as how much am I willing to pay in money to get an additional unit of some good that I want. That's our thinking with the marginal rate of substitution as willingness to pay. But it doesn't only apply to money. It applies to two goods we can trade off against each other. I can trade off some of my learning in order to get more living, or I can go backwards along my indifference curve. I could give up some living in order to get a little more learning. So there we want to make sure that we're thinking of this marginal rate of substitution as how much someone is willing to pay in one good in order to get an additional unit of the other good. Okay. So, why does the marginal rate of substitution tell us her maximum willingness to pay? It tells us it's because she would pay less than the marginal rate of substitution to get more of x, because this would increase her utility. It would put her on a higher indifference curve. She would not pay more than that, though. Okay, so crucially, she would not pay more than her marginal rate of substitution in order to move from one point to another. Right, we're going to delve more deeply into this later as well in this chapter and in later chapters too, let me tell you. Okay, so here we are back at Keiko's indifference map with three different indifference curves for living and learning, two goods that she likes. Okay, so the negative slope of the indifference curve is the marginal rate of substitution of learning y for living x, as we've already said. And we said that the marginal rate of substitution captures the trade-offs of Keiko's preferences for the two goods. Now at point F, Keiko has a high level of learning, 3, and little living. She's got 2 hours basically for leisure and doing other things. That's not too much time. Now the question is she willing to give up more of her learning for living? Or is she more willing to give up living for learning? Okay, that's what we want to think about here. What are the trade-offs that she's willing to make? And then we can also think about comparing this at point F with other points, such as G. Okay, so when we think about x and y and comparing f and h, we're going to think about the different points along her different indifference curves and what she's willing to do. Okay, so the first thing to think about is comparing points f, I, and g. What do we know? In comparing those points that are on different indifference curves, but we can still think about them in terms of the marginal rate of substitution along a given indifference curve. If we look at points f, I, and g, and we compare the marginal rates of substitution at those different points, what can we see? Well, we can see that at point F, she has a very steep indifference curve. That means her marginal rate of substitution is high. At point I, her indifference curve is flatter, and so therefore her marginal rate of substitution is lower. At point G, it's even flatter than it was at I, and as a consequence of that, what do we know? Well, we know that her marginal rate of substitution then is even lower at G than it was at I or F. So comparing different indifference curves, we can see the different levels of the marginal rate of substitution. Keiko is willing to give up the most y for an additional unit of x at f. She's willing to give up some y to get some more x at I, and she's willing to give up the least y to get an additional unit of x at point G. Okay, so that was our first comparison across different indifference curves, looking simply at the different slopes. Now, along the same indifference curve, comparing points F and H, what can we see? Well, at H, her slope is much flatter. The marginal rate of substitution is therefore much lower. Okay, so let's think about this a little bit and think about once more this ratio of marginal utilities, ux over uy. So u sub x, that's a marginal utility of x, u sub y, that's the marginal utility of y. Now, if I'm looking at point F, what we see here is that when I have more of a good, what happens? When I have more of a good that I can consume, that means that my marginal rate of substitution, my marginal utility of that good, as I consume more of it, more and more and more of a given good, what happens? My marginal utility goes down. So as I consume more x or as I consume more y, my marginal utility of x or y must go down. Okay, so as you consume more x or y, your marginal utility of that good goes down. Okay, now what's the intuition here? We can think about this in terms of, say, chocolate bars or cups of coffee or all kinds of things that we might consume. So imagine it was the case that I had, say, one chocolate bar and I could potentially eat another. We could think there, the first chocolate bar probably has positive marginal utility for me. I like consuming it. But the second chocolate bar is not as nice to me. I don't get as much marginal utility from the second chocolate bar as I did from the first. And I don't get as much from the third as I did from the second or the first even. And so we see there this intuition that as I consume more of a good, what happens? The benefits I receive from consuming that good decrease. Now the same is true in terms of the person's preferences here for leisure or leisure on the x-axis in terms of her living, like what she values spending her time on when it is not spent on studying, such as her hobbies or sleep or other kinds of things that she could be doing. Now, that's living. Now, learning is also something that she likes, and she likes the intrinsic benefits of learning, but she also thinks that studying is quite a valuable thing to have done in terms of like the grades that she will actually achieve. So it's good both in terms of the intrinsic value she places on learning, but also the grades she achieves. She likes both of these things, and that goes all into learning. Now, here's the thing. The more and more learning that she gets, though, the less benefit she receives from it. And the same thing for leisure. When she has very little leisure, getting an additional hour is incredibly helpful to her. Having no leisure and then getting 2 hours, that's amazing. Going from 2 to 4, that's not quite as good as going from 0 to 2, but it's really quite nice. But going from 16 to 18 hours of leisure, there's not so much of a difference there in terms of the benefit that's adding to her. And so we can see how this plays out in her indifference curves. So if we look at point F, what do we see? She has high y, right? So relatively speaking, along the vertical axis, what can we see there as y increases? 3 is quite a large number in terms of y. This means that her marginal utility of y, u sub y, is going to be low. She has pretty, almost zero, very little x. So that means that her marginal utility of x is going to be high. Now remember, the marginal rate of substitution, MRS x y, is equal to ux over uy, or u sub x over u sub y, the marginal utility of x over the marginal utility of y. So when she has little x and lots of y, ux is large, u sub y is small. So a large number over a small number, what do we have there when the small number is in the denominator? This means that this fraction is therefore going to be a large number, okay? So the MRS as a whole is going to be large. Now, that's what we had at point F, okay? So that was corresponding to point F. The marginal utility of x was high because she didn't have much x. the marginal utility of y was low because she has quite a lot of y already. Okay, now I'm going to erase this, and then we're going to compare it to what we see at point H. So take a second for yourself. Can you think about what's going to happen at point H? Is it going to be the same as what we did when we were evaluating point F? What can you think there? Take a moment and think about that. I'm going to erase these now. Okay, so you already thought about point H, F, and I've now told you to think about point H. So what do we know? We know that our marginal rate of substitution is equal to the marginal utility of x over the marginal utility of y. Okay, now here's the thing. At point H, what do you have? You have lots of x. So what does that imply? It implies that the marginal utility of x is low. It's a low number. You've got lots of x, therefore your marginal utility of x is low. What you also have, you have little y. That implies the marginal utility of y is high. So what does that imply about your marginal rate of substitution? Your marginal rate of substitution is equal to u sub x over u sub y, or the marginal utility of x over the marginal utility of y. That's equal to a low number divided by a high number. So when we've got a small number divided by a large number, what is that going to give us? It's going to give us a small or low number. So what does that mean? The marginal rate of substitution at point H is going to be low. Right? We can get that intuition just from looking at the figure. So what does that mean? We saw the MRS at point H, sub H, is low. We saw the MRS at point F, MRSF is high. Okay, so at point F, she's willing to pay lots of learning, in order to get a little bit more living. At point H, it's the opposite. She doesn't want to give up much learning in order to get an additional unit of living. In fact, it could be the opposite. She'd actually be willing to pay a significant amount of living in order to get a good chunk more of learning if she could. And so that is how we think about the relationship between diminishing marginal utility and the marginal rate of substitution and willingness to pay.